Welcome to everyone. Today we are going discussing about another topic on computer network, which is congestion control. So what is meant by this congestion control? Right, what is the usage of congestion control, and if there are any limitations are there, how we are able to overcome the limitations of congestion control. And we are discussing about this policy mechanism and what type of policies are there while sharing information from one network to another network. And another important thing, the shortest path algorithm. In the network layer is purely depending upon the routing mechanism, the information transmission protocol mechanism that we are calling as the shortest path algorithm mechanism. So in this session, we are going discussing about these three important topics. One is congestion control, policy, as well as the shortest path algorithm. Right. So while come to this congestion control, what is congestion control? So if any error, for example, n number of informations are transmitted. So if any errors are information transmitted, so due to some network issues or n number of traffic flow condition, heavy traffic density of the situation, some network may slow down. Some networks may be slow down due to maybe data rate values or traffic density values or usage of number of channel values or bandwidth values. So different kind of situations are there. Some network, because of some it goes to be reduces the information transmitter, network is slow down, that we are calling as a congestion control. So what is congestion control? The state occurring in network layer which that measures traffic. The traffic density is very high, based upon that one is slow down the network response time, that we are calling as a congestion control. For example, we are able to allocate the 10 channels are there. For example, we have limited bandwidth is there, we allocated to 10 channels are there. So the 10 channels are allocated to the respective frequency. Every channel is engaged to transmit information or to receive information. So based upon the bandwidth we are able to transmit information, some channel may getting slowed down. That we calling as a congestion control. So for example, I can able to transmit 1 GB information through WhatsApp or else through Google Cloud. So or else D drive condition situation. So based upon the data rate which we have in that one, based upon that one, the information will be transmitted within the seconds or within a minute. So depend upon the network density value, that should be slowed down the information transmitted or received. That phasing situation we are calling as a congestion control situation. But what is the effects of this congestion control? So if the data rate is very low, for example, to download this 1 GB data, if data rate is very high, it takes 10 seconds of time or else 1 minute of time. But data rate is very low, to ensure this 10 seconds, it takes 10 days. Right. So what happened? The delay is increases. It shows performance value. The throughput analysis is very vast, that one. So the performance is decreases. So at the same time, if delay increases, so rate transmission may occur, but due to some issues, because 10-day situation is there. So on that time, the data may lost or packet may discarded. So situation may occur. So rate transmission should be initiated. So that make a noise here. So that is the effects of congestion. But what are types to causes congestion? I will discussing about this, maybe traffic value, but maybe data rate value. But what is exact causes of this congestion mechanism? So when we arrival of sudden streams of packet, and when you go for this, for example, we have to transmit 10 different packets, 1, 2, 3, 1, 10 packets and transmitting. But due to suddenly another packet is entering and to hit this values, to happen a collision may happen, some kind of traffic density may happen. So a sudden stream of packet also may cause the issues of this congestion control, and we having this insufficient memory. So that is also one of the major issues to cause the issue. And we calling as a slow process speed, we having as a low bandwidth, and the traffic is busty. So that may cause the congestion control. For example, assume that one. For example, we having as a traffic density is there, right? So the vehicles are moving like this only, but suddenly another vehicle over there, they hit like this only. So what happens? It may affect the traffic density value. It may affect the all the kind of situation, all the kind of vehicles value, or else all the kind of packet situation value, all kind of frames value. It may take the some kind of delay situation may happen. On the time some kind of collision may happen. So when to retransmit this entire packet or entire frame. At the same time, we having as a traffic value, the bandwidth value, and slow process speed value. That is, all the things are depending upon this thing that may cause the situation we calling as a causes of congestion. But what kind of techniques are there? To congestion control technique, we are using different kinds of techniques are there. Basically, we are calling as a two categories are there. So congestion control is there, but we have to aware the mechanism, we have to control the congestion technique. There are two techniques are there. One is open loop congestion control. Second one is a closed loop congestion control. the congestion control technique, we have two things are there. One is open loop congestion control and second one is a closed loop congestion control. So what is meant by this open loop congestion control? So open loop congestion control, the policies are there. What are the policies? You apply that one. So that should be prevent before it happens, and this should be handled either by the source or by the destination. So when you go for open loop congestion system, so the receiver or what are the information we transmitted, the source section, it already have the information. It has to apply to prevent the before it causes one. Before, like if we are going to estimate that one, they may cause the situation. So we have to understand the situation. We have to prepare for that. We have to prevent the congestion before it happens. So that should be either handled by the source mechanism or should be a destination mechanism. For example, 10 packets are there. So instead of this 10 packet at a time, so based upon dotted value, we send the information packet by packet. Packet will transmitted, after by packet 2, after transmit 3 till 10 values. So here what happened, traffic density should be neutral. So similar manner we can transmit 10 different packets or frames. Because instead of this we transmit 10, we transmit 10 from at a time, it may cause a traffic density value. Right. So that is a reason. We have to understand the mechanism. We have to send the information either one by one mechanism based upon dotted value, or as understand traffic density value, we have to share the information. And next one, what kind of policies are there to adopt the open loop congestion system? We having as a retransmission policy, window policy, discarding policy, acknowledgement policy, as well as admission policy. So n number of policy techniques are there. For example, when you go for this, the retransmission policy, if any transmissions are there, if any packets are failed over there, we go for this a retransmission mechanism. We have to initiate the what are the packet is failed, so that we calling as a retransmission policy, and we calling as a window policy is there. So here transmitter is there as well as receiver is there. So based upon TCP protocol or else RTS system, if we are open, the number of windows are there. If window 1 is busy, like based upon situation of this windows, so the window is either idle position or as busy position or as the traffic position. We understand the window policies, we have to send information one by one, or based upon situation we have to understand and we have to send information to the receiver. And discarding policy, if the delays increases, lot of delay we are getting based upon traffic density value, the delay should increases, so there is no need to transmit information. We simply discard the frame and we have to initiate the retransmission policy. And similarly we have to get the acknowledgement services and admission policy. Because what is acknowledgement? Because the frame 1 or packet 1 successfully transmitted, we get the positive acknowledgement, or as the packet 2 is failed, we get the negative acknowledgement. So some kind of acknowledgement get the receiver, so that we have to follow the policies. And similarly, second one we calling as a closed loop congestion control. So while discussing about this open loop mechanism, similarly we having as a closed loop congestion control is there. So what is meant by this a closed loop congestion control? So when you go for this open loop situation, in the open loop conditions, when you see this previous slide, in the open loop condition, so we have to initiate, we have to understand the traffic density, we have to prevent the mechanism. But in the closed loop, we have to taken care about the situation, like how we are able to transmit information, how we are able to share the information. The end-to-end closed loop policy loop control is there, as well as hop-to-hop closed loop control is there. So we have to understand the closed loop control mechanism. We have to go for this open loop end-to-end situation, or as a closed to closed path is a limited kind of path situation. For example, we have end-to-end path is there. This acting as a source, this acting as a destination. We have to understand the information between end-to-end mechanism, because information is transmitted from 1 to 2, 2 to 3, 3 to 4, 4 to 5. So what are the n number of networks are present in the region, we transmit the information value till end of the destination. So the destination is only send information to the source point, whether it is a positive acknowledgement or negative acknowledgement. So in this one, what happened? End-to-end mechanism is there. So after send on information only, the information is transmitted. But between the session, for example, packet 3 is transmitted or discard is there, connection loss is there. So that may cause the issues over there. So it takes the delay of the information received, delay of the acknowledgement received, that may get the chances. But what is hop-to-hop control? So every hop, information is transmitted, we get the particular acknowledgement. Here what happened? After all the information is transmitted, we get the either positive acknowledgement or negative acknowledgement, that we calling as end-to-end network. But here what happened? So when any kind of network is transmitted, for example, the router information transmitted router 2, so we get the acknowledgement. whether it's a positive value or maybe a negative value. Similarly, 2 to 3, 3 to 4, as well as 4 to 5. So n number of networks are present, so n minus 1 to n. So that kind of thing should happen. We calling as a hop by hop loop control. If any this is failed, so we go for it, we get the A2 acknowledgement, we retransmit the frame. So that may hop to hop situation. So here how this happen? When you see this one, here choke packet is there. For example, information is transmitted from packet 2 to packet 3. Here when you see this one, here A to B is information is there. A to B information is transmitted, similarly B to C, as well as C to D information is transmitted. Here the loop path from information A to E path is there, as well as E to F is there, and F to D. So we have to choose the what kind of the packet mechanism is there and what kind of a choke kind of construction is there. So information is transmitted from this one to other direction. So what kind of choking direction is there? You see this one, information is transmitted. So here what happened? It has to get the reduced flow value, and we have to get the maximum traffic rate, maximum data rate should be handled. At the same time, we have to get the flood kind of thing. So we have to understand the flow is reduced. So if any heavy flow is there, we have to mechanism, choke mechanism, we have to understand the choking construction, we have to reduce the flow value. That is the advantage of this choke packet. And other important thing is a criteria of policy. But where I am using this policy, what is the criteria rate? So if average rate should we have to maintain, and if we go for any kind of peak rate, we have certain kind of criteria condition is there, as well as we have to understand the burst size values only. We go for this different kind of window policy we are using that one, different kind of retransmission policy we are using that one. So we have to understand what kind of average data rate is there and what is peak rate is there when information is transmitted. If any size is there, any kind of burst size occurring, so we have to capture in the information of burst size values as well. So another important thing, the shortest path algorithm. So in the shortest path algorithm, we have two things are there. One is a Dijkstra algorithm, other one is a Bellman-Ford algorithm. Bellman-Ford algorithm. So there are two important algorithms are there to understand the shortest path mechanism. So first one we discussing about is a Dijkstra algorithm. So what is Dijkstra algorithm? Dijkstra algorithm is says that one we have to understand the shortest path between the information is transmitted from the source to destination. But how are we able to understand that one? So when you see this one, for example, A to information is transmitted. So information is transmitted from A to D. So A acting as my source or transmitter and D acting as my receiver or as my destination. We have to able to transmit information from A to D value. So here information what happened? We having options are there. Information transmitted from A to B value or as A to G value. So information is transmitted from A to B. So which is 2 comma A. The distance is 2 and get information from A. So which is 2 comma A. From similarly here 6 comma A. The next one we have information transmitted from B to E path or as B to C path. We have as options of B to E or as B to C or as G to E or as G to H. So here we choose the information. Which is the shortest path? So 2 is the shortest path. You have to pick 2. So next one, we have to move information from B to E, not G to E. We have to information from B to E because B to A is 2 comma A and A to G is 6 comma A. So what is shortest path? 2 comma A shortest path. We have to pick that path which is 2 comma A path. So information once from information from A to B is there. So here B acting as a source. The information transmit to E. What is the distance? Which is 2. 2 plus 2, 4. So here E comma is which is 4 comma B. What is 4? The distance value. What is B? The next what are the information getting from the router, which is B router. Again, we have these options are there. Information from either E to G or else E to F. But E to G is always a long distance. We have only one option which is E to F. That is 6 comma E. Next order is 6 comma E. Once F is received, we have these options of F to C, F to H. What is F to C distance? So here we having as F to C is 3 and F to H is 2. We have to calculate that one and move information to F to H, which is 6 plus 2, 8. And finally 8 H to D. The information is received. So that is a Dijkstra algorithm. We have to choose the shortest path. First we have to analyze the n number of directions. We have to analyze the A to B path as well as A to G path. Then we have to choose A to B as the shortest path. That is the advantage of this Dijkstra algorithm. Similarly, what is Bellman-Ford algorithm? This is also more or less similar to Dijkstra algorithm, but here the compute the line cost from the starting node is every directly connected to the node. So in the previously we have to understand the each and every routing path. So here also we have to compute the line cost from a starting node to till end of the connected, end of the direct node values only. So here we have to choose a selective path, which is the cheapest link for every node, which is if either there is more than one links are present, so that we have to analyze the link mechanism, which is the cheapest link mechanism. At the same time, every directly connected node, which is a compute the long cost, which is all the nearby nodes value, we have to analyze how much compute cost is there, how much amount of distance is there, we have to compute the link cost for this every routing mechanism, every kind of hop mechanism. So after this one, we have to choose a cheap route path, cheapest route path. So if this process repeat until the data is successfully received. So in the Dijkstra algorithm, it is slower than the Dijkstra algorithm, but it's a more versatile and it is capable to handle the negative weight edge values only. It having as a capable to handle some kind of negative weight edge. That is advantage of this Bellman-Ford algorithm. The Bellman-Ford algorithm and Dijkstra algorithm more or less similar, but we have to understand the compute cost and whatever the things are versatile mechanism. If n number of situations or the n number of routers are present over there, how we are able to handle that one with the help of the directly connected node, that is important to us to analyze the shortest path, the information is transferred from source to destination. So next one is we have to maintain the QoS. What is QoS? Is a quality of services. We have to transfer information, but we have to maintain some kind of quality of services, because the quality of service is very important to any kind of structural algorithm to maintain the information carrier prospective value or data rate prospective value or accuracy prospective value. So here, what is quality of services? A stream of packet from source destination, we calling as a flow mechanism. So here, every flow, this can be characterized as a 4 parameter. When information is transmitted, we have to characterize 4 parameter. One is reliability, delay, jitter and bandwidth. What is reliability? So, and what is delay, and what is jitter, and what is bandwidth? So if you go for this, the reliable connect services, and if we that how much kind of accuracy is there, how much kind of efficiency is there, so we have to understand the reliability and what is the granularity level, that is calling as we have to maintain the information transfer from source destination, that we calling as the reliable services are there. And if any delay should be happens, what kind of action we initiated, whether go for this retransmission or else resend information, so we have to understand delay mechanism, as well as a jitter kind of any kind of congestion should be happens, any kind of jittering should be happens. We have to analyze the things, maintain the flow character value, and similarly we have to maintain the either should be uniform bandwidth, or else if the channel is ideal, we have to choose the bandwidth to the next available channel. So what is the techniques we follow that one? We have to follow the scheduling mechanism, a traffic shaping mechanism, resource reservation mechanism, as well as admission control mechanism. So when information is transmitted, n number of packets are transmitted, we have to follow the schedule. So first we have to move frame 1, next frame 2, after successfully receiving frame 2, frame 3, next successfully receiving frame 4. If not, retransmit the same frame. So we have to give the scheduling kind of architecture, so that we calling as a quality of services. And we have to maintain the traffic shaping as well. So what kind of path we are choosing that one, what kind of traffic density is there. So we have to understand the traffic flow from the source to receiver, as well as the receiver availability as well. So which means a resource reservation value, which means we have to transmit information, we have to choose the resource value, we have to go for this reservation of the resource, that the values. So I conclude this session. So in this session, we are discussing about the important topic, which is what is congestion control, what is policing, and what is the shortest path algorithm. So what is congestion control? In the congestion control mechanism, so how much amount of information is there? If any failure should be happens based upon the traffic value or a traffic density value, the delay value, what kind of density should be, what kind of initiation should be happens, what kind of failure should be happens, that we calling as a congestion value. So if any congestion should be happens, how we are able to overcome that one, that we calling as a control value, we calling as a congestion control value. And the next one we calling as a policy mechanism, which means we having as window policing or admission control policy or acknowledgement policies to overcome the scenarios to successful transmission path value. At the same time, important thing in the routing protocol, that is the shortest path algorithm, which is Bellman-Ford algorithm, or else the Dijkstra algorithm, to share the information from, to transmit the information from one point to another point. So we have to choose a prescribed path for that one. So that is a calling as a shortest path algorithm. So here as we discussing about this QA mechanism, which we calling as a quality of service mechanism. So that's what we discuss in this session. So in the next session, we are going to discussing about the important topic, which we calling as a scheduling mechanism, as well as queue mechanism. So what is the scheduling mechanism? How we are able to schedule the information things, availability analysis things, because when we say about this quality of services, we discussing about the slide, we have to maintain the scheduling values, we have to maintain the window policy values. So we have to maintain the admission control values, because we have to follow the reliability, jitter, and we go for this respective bandwidth structure values, the flow control things values. We have to maintain the important things. There should be a scheduling mechanism value. So in the next thing, we are discussing about is what is the scheduling policy values, and if any queues are there, any kind of stack mechanism is there, how we are able to queue the things, that we discuss in the next session. Thank you.